Yeah, good morning. Thank you for coming so early. Usually I'm not awake at these kind of hours. Okay, so let's start. So today we're going to talk about two new tools that we developed at Javelin Networks, and we will make them available for you. We will talk how we got to them, so we will need to start by talking about PowerShell in red and blue. How many people have been to the training for PowerShell? Yeah, amazing. And we'll have to go into a little bit into the internals of Dotnet and PowerShell to understand what happens behind the scenes. And lastly, we'll need to understand how you hook Dotnet assemblies. But let's start with the beginning. So who am I? I'm Omer. I manage the endpoint team at Javelin Networks. We protect the Active Directory from the endpoint. I have more than a decade experience. When I mean a decade, I'm talking about a full-time job. I started working when I was 14 at Microsoft. I've been, like many of the Israelis in the industry, I did my time in the intelligence corps. I developed medical imaging software for about 6 years, and I also been a malware researcher at IBM Trustir for 2 years. And for the past 2 years, I've been with Javelin Networks. I also have a BFA in photography. And I also started my first steps with traditional woodworking, which is working with solid wood without power tools. Okay, so let's start. I have to give you a heads up. When we talk about PowerShell attacks, we are so way up high on the cliff that we don't know what happens beneath our feet. And in order to understand all the things I'm about to talk to you about, we have to jump from the top of the cliff down into the deepest layers of assembly. So we have in the middle, usually it starts with a phishing attack, then it goes to PowerShell scripts, and PowerShell scripts run on the PowerShell engine, and PowerShell engine is System Management Automation DLL, which I hope all of you know by now. And the System Management Automation DLL is a .NET DLL, so it works on the .NET framework, and that works on Windows, and at the end it goes back to assembly. So we'll have to jump all the way down to the assembly and then jump back up to the PowerShell. And by doing so, I can show you how we can both reveal and increase the security of PowerShell and also defeat all the security features in my PowerShell. But then again, we don't have enough time to talk about all of this, so I won't dive into the tiny details. I will try to dumb it down the most I can. Microsoft uses GEA for just enough administration. I will use GEA for just enough amusement when I give my explanations. Okay, so we have to start by talking about the elephant in the room. PowerShell is not an exploitation tool. And it's important to understand that PowerShell is always used post-exploitation. And when I say that, it means that when an attacker runs PowerShell on your machine, she already has the ability to execute any code she wants on that machine. However, PowerShell does have a powerful feature for attackers, which it allows them to live off the land, which means they don't need to drop any file to disk. They can just run PowerShell and the script inside, and the IOCs that you get will be much fewer than if a file would have been dropped. There are many tools that use PowerShell. I don't need to list you know, Empire and a lot of other stuff. And we have to start looking at it by looking at a real attack. So I will tell you about a report by Michael Gorelik about FIN7. FIN7, sometimes they are referred as Carbonac. It's a financially motivated threat actor, and they primarily target the retail and the hospitality business. There are 3,600 known compromised locations, and they stole over 15 million credit cards so far. Their toolset is constantly evolving, and it relies heavily on obfuscation. They are using cutting-edge technology. They watch all the conferences. They know their stuff. Last August, 3 members were arrested from the team, but don't sleep thinking that everything okay, the group operation still persists. So how everything starts? As usual, it all starts with a phishing attack. And of course, you are all in security, you are all aware that you should not click enable macros, but if you run a business and you get a letter of demand from an angry customer, you will click the enable macros. We are not on the same level. We are doing IT stuff, they are managing a business, and it's completely different. So when you click that enable macro, what happens in the background is that a VBA script runs. And as you can see, that VBA script invokes PowerShell. And just to show you their sophistication, they are not invoking PowerShell straight from Word document. They're using WMI. So if you have endpoint protection that you relied on, the next gen, to catch that PowerShell exe is a child process of Word exe, that won't happen. Because PowerShell will be a child process of WMI. And it will also be on the services, so it will also be on session 0. So your endpoint protection is caught off guard on this instance. But it's also important to note, as I said before, that an attacker doesn't have to run PowerShell. This is an example of running shellcode script from VBA by Matt Wicks. It was published in 2012, so you know how all this thing is. It's also incorporated into Metasploit, and it allows you to run any shellcode you want. So that means you can also reflectively load DLLs into the word process, and you can do whatever you want with the process. But let's get back to Fin7. So after a few steps of deobfuscation of the script looks like this. If you're asking yourself, what are all those slashes and stuff? Those are variable names and function names. So if you deobfuscate it a little bit more, you can find the encrypt, the crypt, and the logic function of the module. And what it does, it communicates with the command and control server through DNS. So again, if you had firewall that you trusted to block their communication, they are passing through your firewalls, they are passing through every security mechanism you know. We can't talk about PowerShell attacks without talking about obfuscation, and the most comprehensive tool that we know is Invoke Obfuscation by Daniel Bohannon, which he wrote based on obfuscation techniques that he's seen on the wild. It's not stuff that he made up. This is stuff that actually exists and is used by threat actors. It's important to note that Daniel and Lee Holmes also developed a tool called Revoke Obfuscation that allows you to detect obfuscated scripts offline. And offline is an important remark. So let's see some examples about obfuscation. I'll start with the most simple command, who am I? Every attacker would like to run this command on your machine, but it also gets a little philosophical when you start to lose your own identity. So you can do string token manipulation, and you can split the string. You can also reverse the order. You can also use compression. And you can also use what the fuck is this? But this is, this is who am I? So you might feel a little bit discouraged, but don't be. Microsoft came to the rescue, and they published PowerShell Hearts, the Blue Team, which is Microsoft Bible for PowerShell security. And every time I see Lee Holmes, see you here in the audience, thank you for coming, I see a person that he understands security, because sometimes when we talk and we do our research, we get caught up with the technical details of specific stuff that we forget to see the whole picture. And when Lee Holmes talks about it, you see that he mentions all the time that the attacker has the ability to run code. And he has, or she has, the ability to bypass a lot of protection mechanisms that you have. And the best thing you can have is to have visibility on the attack. Because once you have visibility, you can trace back the attack and find out what happened and what was compromised exactly. So let's see all the security features that are incorporated into PowerShell. The first one is script block logging. So every time, or most of the time that a script is being evaluated, it will save you the script block. And this feature is enabled by default for suspicious scripts. So you don't need to enable it, but you should enable it for all the scripts that run on your machine, because that's a really good visibility feature. The next one is a pipeline or module logging, which gives you much more information on each script that you run and each command that is invoked, a PowerShell command. The next one is transcription or over-the-shoulder logging. And that one logs for each process of PowerShell. And again, when I'm saying PowerShell, it's system management automation every time that DLL is loaded into somewhere. And it saves the input and output of the shell. So for each process, you will get a TXT file like this. Gives you a lot of detail about the session and all the input output. Microsoft recommends that you create a shared folder and you give everyone permission to write and create on that folder, but you add the creator owner deny on everything. So this is like a game of ACLs, which allows everyone to create and write the logs, but no one can actually list the folder and delete the files after it has been created. So this is also a powerful logging mechanism, and it gives you a lot of visibility on what happened on attacks. There are two more features. Before that, the constrained language mode is another feature that allows you to, as it says, as the name suggests, constrain the actions you can perform on the PowerShell on PowerShell. So you won't be able to execute commands that have the ability to be malicious. Two more features that we have are protected event logging and just enough administration. I won't go into the details because it's not related to our talk, but I'll just say protected event logging allows you to use asymmetric encryption on the log, so you won't have clear text passwords on the logs. And just enough administration is a concept that you can limit users of remote PowerShell to specific tasks, so they won't be able to execute anything other than they should. And now we're getting to the crown jewel of PowerShell, which is the anti-malware scan interface. And it's actually not a PowerShell feature, it's a Windows 10 feature. And the way it works is that every person that writes the software can interact with it, and in this case, PowerShell. Before running scripts, it goes to AMSI, say, hey dude, I have this script, do you think it's okay? And AMSI looks at the script, say, let me check this out for you. And it takes it to all the endpoint protection that you have on your machine, the ones that are using MSI, and tells them, look dude, this PowerShell gave me this script, do you think it's okay to run them? They look at it, and then Windows Defender say, nah, I know this one, this is malicious, don't do it. So it goes back to PowerShell, and PowerShell says, well, okay, so I won't run it. And yeah, so this is basically how it works. It's just asking for permission to do stuff. Those are the vendors that currently support AMSI, so obviously Windows Defender, AVG, Bitdefender, ESET, Dr. Web, Avast, and Kaspersky, and CrowdStrike. But there is a problem with AMSI because, as I said before, when an attacker is executing code in your system, she already has the ability to do what she wants with the user space. And this is the user space that is vulnerable, because once you have execution permission, you can modify every part of these layers. And what I will show you later is that there is another layer that all of us forgot, which is the .NET framework. So let's see some bypasses to AMSI, and this is one of the most known. It's an AMSI bypass with a single tweet. And it was written by Matt Graeber. And the way PowerShell works, the first time it needs to call AMSI, it will try to initiate, it will try to load the DLL, and if it fails, it saves a Boolean flag saying that the initialization failed, and it will not try to call AMSI again. So what Matt did, he just used reflection to find this flag and set it to true, so PowerShell will never call AMSI again. But this line is now, this script is now known to Microsoft, so they added it to AMSI because it has to pass first through AMSI to be evaluated. But again, if you use some obfuscation, you can bypass AMSI for detecting this script. So this is like the top layer of PowerShell bypass. Let's see another bypass that attacks the Win32 layer. And this is a research by Avi Gimpel. And what he did, he just overwrites 3 bytes on AMSI DLL, on the function that checks your buffers. And what happens from now on is that whenever you call the AMSI scan buffer function, it thinks that the length of the string is 0. So it will tell you, yeah, a 0 string is always legit. You can run it. So that was the lower level. And this is like really troubling. This is one of the things that got me started in this research to do the Babel Shellfish. And this is work by Ryan Cobb that he published last Derbycon. It's a tool called PSAMSI, and it allows you to write one big malicious script and feed it to AMSI. And now AMSIs tell you exactly which lines are offending AMSI, and this tool also allows you to minimally obfuscate those specific lines to allow them to bypass AMSI. So this bypass is like a bypass to the 3rd level, the level of the security vendors, and not on the Win32 or the Powershell process. So this is like a very powerful, and I got wondering why you can bypass the security vendors with such a simple obfuscation. So I placed a hook on AMSI scan content, and I wanted to see what strings that it get. So I gave it who am I, and obviously I got who am I. And then I gave it what the fuck, and then I got each line is another call to AMSI scan buffer, and you're still seeing what the fuck here, but wait, it gets better. Then you can see that the last 2 lines are human readable, and the most importantly, they are regex readable, because this is how your endpoint security checks for those lines. So that's a good job, Microsoft, but still, how is it possible that you bypass AMSI with simple obfuscation? So I gave it this simple obfuscation technique, the string token manipulation. I fed it, and that's it. That's the only line that AMSI gets. So I started wondering, why is this happening? And I got a solution how to make it better. So the solution is obviously Babel Shellfish. And do you want to see a demo? Okay, so Babel Shellfish is 2 DLLs, the core profiler and the Babel Shellfish .NET module. You have a fancy installation batch script that you can provide it with parameters if you want to output to the debug out, if you want to scan the content with the AMSI, if you want to log the AMSI too, and the folders for the logs and the DLLs for the Babel Shellfish. And now when you run PowerShell, you already have Babel Shellfish inside. And it doesn't matter which way you run PowerShell, even not PowerShell methods will load the AMSI with it. And the logs are saved in the same format as the transcription. It's actually the same code. I stole it from PowerShell. Thank you, PowerShell. And if you run who am I, you can see the command. But then you can see that Babel Shellfish also sees the exact process that was executed when you run that command. And let's try something a little bit more complicated. Okay, I exit because there is a caching mechanism, and sometimes AMSI won't be called if you run if you run the same command. So now we'll run the obfuscated command, and we will look at what AMSI sees and what Babel Shellfish sees. So now you can see that AMSI got the script. Babel Shellfish also got the script, the obfuscated script, but it also got, again, the same process that you execute with the parameters that the process was executed with. And this is something that AMSI, as you can see, can't get. So let's do something a little bit more complicated. Let's try Matt Graber's line. So we will enable Windows Defender to protect our PowerShell script. And the worst thing about Windows Defender when you do this kind of demonstrations, that it just pops so many notifications because it's a test machine. Obviously, it has threats on it. So if we run the command as it should be, you can see that Windows Defender manages to catch it and block the script. And what we'll do next, we will use an obfuscated command, and we will see what AMSI sees and what Babel Shellfish sees. So now we'll take the minimally obfuscated command, which is the same command as Matt Graber's AMSI bypass. And if we run it, you see that it bypassed AMSI. We are now practically disabled AMSI on the system. And you can see also, again, AMSI gets the obfuscated script. Babel Shellfish also get the AMSI obfuscated script, but now AMSI sees all the invocation. You can see it. You can see that it's looking for the type AMSI utils. You can see that it's looking for the field of AMSI init failed with the non-public and static parameters. And you can also see that it has invocation for the set value to set it to true. So this is what AMSI should have got when the Powershell team developed it. Okay, so as you've seen, if you want to use the Babel Shellfish, it has a fancy batch script that installs it. You can give it the parameter if you want to see the debug output. If you are now debugging a script and you want to see what happens in real time, you can use this one. You can send the strings to AMSI to scan them. I haven't got to a point where it actually manages to catch things. I think it tries to do some kind of tokenizing behind the scenes, so it's not the same language that it talks. But if AMSI will find something malicious, it will stop execution. And this is what I told you about revoke obfuscation that works on offline. Babel Shellfish works online. So you can run malicious scripts, and if AMSIs find them malicious after doing all those layers of deobfuscation, it will stop your script. So it's another layer of protection, but I wouldn't suggest it. You will use it as your own security mechanism. It's still a POC code, and you still have a lot to implement in there. You can also log AMSI scripts. Again, it's just for curiosity if you want to see what AMSI sees. You can give it a path for the log folder to be saved. As you've seen, it's like the transcription folder. And you need to give it the path for the Babel Shellfish DLL, so it can register those DLLs. You need administrator privileges to register to install Babel Shellfish. And I think I should add another uninstall batch script later. So how does Babel Shellfish works and how we wrote it? First, we need to understand the internals of Powershell. And when I told you before, I gave you the heads up that we are going to jump off the cliff, this is where we start the jump. So join me into one of the highest jumps in security. So Powershell has 4 parts that you need to know about. The first one is the tokenizer, then you have the abstract syntax tree, then the pipeline processor, and the command processor. The tokenizer splits your text into lexical units, which means it gives them meaning. So it sees the first one and knows that it's operator, it's a group start, a string, and so on and so on. But I think only when you see this kind of division into lexical units, it's much easier to understand how a script block looks like. So every script block starts with a script block AST and a name block AST. They have also the pipeline, which I will explain later, and you can see the commands. But now, when you've seen the tokenizer, it's easier to understand what each command does and what are the parameters for each commands. But it's also important to understand that now AST doesn't contain any meaningful information. It just knows that it needs to run a command. It doesn't know what the command is. And AST will be compiled into expression object, which is the actual object that PowerShell can run. And only during the execution, the object will have the actual meaning, the actual script that it needs to run. So when you compile an AST into a compiled script block, this is the code from Microsoft, and I'm not making this up. They actually call the function really compile, not compile. And those are the 2 functions that you need to be aware of: perform security checks, which calls AMSI, and log compile star, which logs the script block code. So Those are the points that Microsoft chose to protect the scripts, and it's a logical place to put this. I'm not saying anything bad about it, but it happens before the compilation. So the only notion that the script has now is just the original obfuscated script. And the only time it will be called again, it's if it will have to regenerate a new script log. And it happens on certain types of evaluation. It doesn't happen on all kinds of evaluation of scripts. So next in line is the pipeline processor. And this is the actual mechanism that runs your commands, and it needs to take the output from one command and pass it as the input for the next command. But how does it run the commands? It uses the command processor. And the command processor, it's actually a base class that has three classes that inherit from it. A script command processor, which runs actual scripts. You have the command processor that runs C# compiled commandlets, and the native command processor that runs processes. There's another class, DLR script command, which is actually the class that makes all the implementation of the script, command script. But now you can start getting the idea why AMSI is easily bypassed. Because AMSI and the script log logging works when you compile the AST into script log, into execution object. And what we understood in Javelin is that we had to implement Babel Shellfish on the command processor and on the compiler. So we analyzed the Powershell code and we placed hooks on each one of those command processors, and also we inserted some code into the compiler, and we hook all of those functions on runtime when Babel Shellfish loads with Powershell. So now that you are experts on Powershell, let's see if you can also be experts on Dotnet and CLR. This is the time that I mentioned just enough amusement, because there is no way I can explain to you how .NET works in 5 minutes or maybe less. So I will use analogy. The Greeks used it to explain complex stories and complex stuff. So I will also use analogy. I hope you will follow me along. Let's think about the CLR as a ruminant digestive system. So if the field is the CPU and Windows is the cow, and CLR, as we said, is the digestive system, you feed it with C# and VB code. You take it through the CLR compiler, and you get IL assemblies at the end. And IL assemblies are not assemblies that you can run, because IL stands for intermediate language. It's not assembly code that your CPU can digest. So you need to pass it through another mechanism, and there are two mechanisms to turn the IL assemblies into assembly. The first one is JIT. It stands for just-in-time compiler, and the CLR, when it loads your DLL, every time you call a function for the first time, at that specific moment, it will compile it into assembly code. And it might sound like it takes a lot of resources, so you can pre-compile those assemblies using Engine. So Engine creates a pre-JITed assemblies, and those assemblies contain both the IL code and the assembly code that can be run. And this is important thing that you need to remember, because I will mention it later. And once you have those assemblies, you can feed it to the last stomach, the CLR hosting, that knows how to run those assemblies and feed it and shit on the CPU. Yeah, I just compared Microsoft to a cow and no one blinked in the room. Okay, so now it's time to learn how to hook .NET assemblies, and there is a great paper that Emmanuel Rousseau, I don't know how to pronounce the names. If I pronounce your name wrong, blame your parents. She wrote Hijacking .NET to Defend PowerShell, and she lists the known methods to hook .NET assemblies. And one thing that she mentions throughout her research is that it's very, very problematic to hook pre-JITed code, because all the known methods are usually either replacing the IL code or waiting for the JIT to happen. And it's hard to do it, or it was at least impossible until now to do it. The things that the method that she suggests is a get function pointer, which I'll explain a little bit later, which hooks the assembly code after it was JITed. Another good research, it was done by Satoshi Tanda, Powershell Inside Out. And he gave POC code that actually runs, and he uses reflection to find PowerShell's method. Specifically, it's scan content. It's the function that calls AMSI. And then he uses get function pointer on that scan content function to find the assembly, the address of the assembly code, and hook that location. So this is a good method to incorporate AMSI into previous versions of Windows if you are developing endpoint security. But then again, it has all the limitation that AMSI has because it sees what AMSI would have seen. So now let's see how we can actually hook also pre-JITed assemblies. And I didn't know what to do at first. .NET is a huge framework, so I asked the only one that knows everything in the world, Google. So I asked Google, hey Google, do you know where I can find native code in all of the .NET documentation? And lo and behold, the first answer it gives me, it's get code info, and that sounds interesting. So I looked into it. And get code info is a part of the CLR profiler. I'll explain a little bit what it is later. And it gives you the assembly code address of those functions. And it doesn't matter if those functions were pre-JITed or JITed or just-in-time compiled. So that's a powerful thing that we can use. So what is the CLR profiler? It's available from the .NET 1, so you can use it on any .NET version, even on PowerShell 2.0 if you want. The CLR profiler is a COM object that you need to write, so it's unmanaged DLL, and it cannot contact any managed code because then the CLR will just lose its mind. You don't have to have administrative privileges to run CLR profiler, and this is important for attackers. And you don't also have to register it as a COM object. There are two methods to do it. You can either call the iCLR profiler attach profiler to attach it to a running process, or you can use the environment variable CLR profiler path that will give you the same functionality to load the COM object from a path and not from the registry of the COM objects. And the important thing is that you can get the JITed code address. This is what we want. And another thing that you need to remember, you can unload the profiler DLL. So from attacker perspective, you can load the CLR, you can hook the functions, and then unload the profiler, and you will not have any DLL loaded into your process memory. So forensics tools will not see the CLR profiler on that in there. And another thing that it's worth mentioning, CLR profiler is used as a known UIC bypass. And as you know, UIC is not a security boundary, so Microsoft won't fix it. It was reported last May by Casey Smith. So it can also be used for disadvantage. And this is the big but. There is another way. When I did my research, I found at least 4 methods to hook .NET assemblies that can hook pre-JITed code. And each one has its own advantages and disadvantages. And one method in particular allows you to leave off the land, which means you can hook .NET assemblies without leaving any trace on the target process, without leaving any trace on disk. You don't need to do any of that. And as you've seen, the CLR profiler, you need to write a file to disk. And I'm currently in the process of doing responsible disclosure with Microsoft. So after this process will be done, I will release the code for this hooking mechanism. And for now, I felt safer to use just the CLR profiler to show it to the community. And again, if anyone wants to know the method to protect, if you're developing endpoint protection and you want to add this protection or to know what the method about, just contact me, and I won't hide any information. We need to know about it. So now we have a way to get the address of the assembly code in memory. and we need to hook them. So the method that we use for the past decades to hook assembly calls is inline hooks, and now we finally got to assembly. Remember the cliff that we had to jump from? We just got to the pool of assembly now. So how does inline hooks works? This is the original function assembly code. In this case, this is scan content that calls AMSI. You can see it does the usual stuff. It pushes registers, it allocates places it allocates space on stack and starts moving stuff all around. And when you hook, the hooking engine actually replaces the first bytes of that function with a jump to the hook function. So whenever someone calls that function, it will immediately jump to your hook function. But now you have a problem, because maybe the hook function wants to get the original function functionality. So the hooking engine creates something called a trampoline, which is a copy of the first bytes that it overwritten with a jump opcode that jumps after the jump. So essentially, if you run the commands one by one from the trampoline, you get the original functionality without jumping into your hook function. But we have a problem with .NET, because .NET cannot call directly into pointers. You need to pass this pointer of the trampoline to the hook function so it knows how to call it. And .NET cannot call pointers, or at least is not supposed. You can call pointers with .NET, but let's assume that you can't. So how you solve this problem? You have the original function, and when you write your hook function, you call a dummy function and you define this function, and you need to define it with some code so the CLR, the JIT compiler will not remove it completely. And what you do, you hook the original function as before, so now everyone calling the original function will be redirected to your hook function. And it creates also the trampoline. So now the next step you do, you hook the dummy function and pass it the trampoline as the pointer of the hook function. So whenever your hook functions call the dummy function, it will actually call the original function to get the original functionality, and .NET will not know that the function was hooked. Okay, so now that you know how to hook functions, let's see what Invisi-Shell can do for the red team. So Invisi-Shell hooks all of PowerShell function, and again, when I say PowerShell, I mean system management automation. It doesn't matter how you load PowerShell, how you load the PowerShell engine, it will be hooked. It hooks system core DLL, and I don't know any other method of hooking IL assemblies that can hook this DLL. And it hooks, obviously, all the calls to AMSI. But then again, there is no need to actually place a hook function, because we don't want the functions that log the messages to do anything. We just add a ret opcode instead of adding a jump, as I've shown you before. So we don't even need to load any other DLL except for the CLR profiler to find those functions and hook them. You can run Invisi-Shell either with admin privileges or without. And it detaches after it hooks all the functions. So again, forensics tools will not see the CLR, the Invisi-Shell on the target process. So we want to see how it works. What? No. You can run it either as admin, as I've shown before with the CLR path, or non-admin, but then you need to register it as a COM object. So it will make a little bit noise in the registry. Okay, so I set up the machine with the top security. We have the script block logging, module logging, and the transcription. And we also have Windows Defender running in the background. And if I try to run invoke Mimikatz, plain sight, I don't try to obfuscate anything, I am blocked by Windows Defender. So I will try to also run it with constrained language mode. And now you will see that I'm not blocked by Windows, I'm blocked by PowerShell because I cannot run this command in constrained language mode. Okay, so you can see that the transcription was created. I will just clean all the logs so we won't be confused if our PowerShell created the logs or transcription. You can see that it logs everything, and we'll clean the logs. And Windows Defender keeps popping all the messages all the time. Please relax. Okay, so Invisi-Shell is actually just the Invisi-Shell DLL, which is a CLR profiler. You can run it either as admin or non-admin, fancy batch scripts. We will run it as admin because we want to invoke Mimikatz. And now you have PowerShell with Invisi-Shell inside. So the first thing I'll do, I'll move into constrained language mode, and then I will run invoke Mimikatz in plain sight without any obfuscation. Do you think Windows Defender will find it? No, it didn't. You get all the passwords, all the stuff you need, and you didn't have to obfuscate any of your scripts. But this is not the main issue. You don't have any transcription written to disk. You don't have any logs written. This is actually an invisible method to run PowerShell. Second. Yeah, that DLL is loaded, but is loaded from the CLR hosting. So some processes will see it as, some endpoint protections will see it as legit action because it's legitimate to load a CLR profiler into a .NET process. And as far as I'm concerned, I don't know any endpoint protection that protects against loading CLR profiler into your process. Yeah, you will see the DLL loaded into that process, but after it finishes the operation, it will unload. So you will get the log that the DLL was loaded if you are monitoring it online, but you won't get the DLL. You won't see the DLL if you try to get forensics after it was loaded and finished the operation. Exactly. No, it doesn't need to be assigned DLL. No, you don't need to sign the CLR profiler DLL, but the CLR hosting loads it for you. So it is loaded as if it is trusted, and as I said before, there is a UAC bypass. If you define CLR profiler for user if you don't have administrative privileges, and load process with administrative privileges, the CLR will load your CLR profiler, even though that you didn't have the privileges to register it as an administrator. Okay, so this was a group effort. Maybe I'm talking here, but there is a whole team behind me that helped in this research. So please give a round of applause to Eyal Naimani, our forensics expert, to Guy Franco, our CTO, that you can drop him anywhere in the world and he will tell you what good restaurants to go to. Ephraim Neuberger from my team, which is one of the brightest developers I got to work with. And lastly, Yossi Sassi, he might be a world expert in PowerShell and Active Directory security, but he's a guitar legend. And if the only thing you will take from this talk is that you'll open your iTunes or Spotify and look for Yossi Sassi and the Oriental Orchestra or any other of his projects, I promise you it will be well worth your time. So the takeaways that you should take with you. You need to know that there is a way to hook .NET without leaving any trace on disk. The industry needs to be aware of that. We can also use the .NET hooks to enhance our security and visibility. So we did the research. Please, Endpoint Solutions, take that research and implement it in your solutions. Next, Microsoft, please improve AMSI. I have to say, maybe I bashed them a little bit, but PowerShell was written by very good developers. I've seen the code. It's amazing code. They have very bright developers, but they did miss some stuff in security, and I know how hard it is to hire people that know security and know good development. I'm also looking for 2 positions in my team. So I don't want to hold this against them, but please, Microsoft, see what we did with Babel Shellfish and see if you can also take it and implement it into PowerShell next, because we don't really need to hook PowerShell to get the security. It should be already built into PowerShell. And lastly, let's break it to make it better. So thank you. I have the resources if you want about stuff that I mentioned. lastly, I will publish the code on my Twitter account, so follow me to get. Okay, so if anyone has any questions, I think we have enough time. Yeah? We have 5 minutes for questions.
Did you test this against any EDR tools?
So the question was if I tested it against EDR tools. No, I didn't.
Go back on the slide.
Yeah. Okay, thank you very much.